In this video, we're going to take a look at the Taylor and the Mclaurin series. And we want to find a series for f of x is equal to sine 2x. And our general form for the Taylor and Mclaurin series that we're going to use to produce it is f of x is equal to the sum from n is equal to 0 to infinity of f to the n of a divided by n factorial times x minus a to the n. And a is our center. So for the Taylor series, we'll have an a value that is not 0, and then the Mclaurin series is a special case of the Taylor where we're centered at 0. So the work for Taylor and Mclaurin is the same, and you'll either have a 0 here for a for Mclaurin, or you'll have a number here for a representing the center of a Taylor series. So the first thing we want to do is take the derivative enough times to where we can find a pattern. So we're going to have f of x is equal to sine 2x, and now f prime of x is equal to 2 cosine 2x. F double prime of x is equal to negative 4 sine 2x. F triple prime of x is equal to negative 8 cosine of 2x. F to the fourth prime of x is equal to 16 sine of 2x. And I'm going to do one more. Usually we only need the fourth derivative, but this function is going to give us some 0 values, so I want to do one more. So f to the fifth prime of x is equal to 32 cosine of 2x. And now we want to evaluate f of x and all its derivatives at 0. So we want to find f of 0, and that is equal to 0. The sine of 0 is 0. F prime of 0 is equal to 2. F double prime of 0 is equal to 0. F triple prime of 0 is equal to negative 8. F 4 prime of 0 is equal to 0. And f 5 prime of 0 is equal to 32. So we're going to look at all our non-zero terms, and we can see that we go from 2 to negative 8 to 32. So that means we're going to have a negative 1 to the n because we're going to alternate the signs of our series. And now we want to look at some patterns. So we have sine 2x is equal to f to the n of 0 over n factorial times x minus 0 to the n. And now if n is equal to 0, we have 0. So this is n is equal to 0. If n is equal to 1, we would have 2x over 1 factorial, and this is n is equal to 1. And then we would have 0 x squared over 2 factorial at n is equal to 2. And at n is equal to 3, we have a negative 8 x cubed divided by 3 factorial, and that's when n is equal to 3. And then n is equal to 4 would be 0 x to the fourth over 4 factorial. And then we have plus 32 x to the fifth over 5 factorial when n is equal to 5. And now I'm going to write all my non-zero terms. So I have 2x over 1 factorial minus 8x cubed divided by 3 factorial plus 32 x to the fifth over 5 factorial. And we're going to say that this is equal to the sum, as n goes from 0 to infinity, of -1 to the n. We'll take care of our alternating signs. And then we have a pattern here. We can see that we can write each numerator as a factor of 2x. So we have 2x here. We have 2x cubed here. And we have 2x to the fifth here. So we're going to say that this is 2x. And now, if n is 0 and we want 2x, that means we need n to equal 1. So we have a pattern of 2n plus 1. So when n is 0, the top would be 2x, because -1 to the 0 is +1. And then we would have 2x to the first, which is our 2x. And then when n is equal to 1, we'd have negative, which gives us our negative. And then 2x raised to the 2 plus 1 is 3, so cubed, and so on. And then divided by 2n plus 1 factorial, because we have the same pattern in the denominator, 1, 3, and then 5. So this is our Mclaurin series of sine 2x. And that's our video on Taylor and Mclaurin series.